Hello all, this is Priyadashni working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with our next lecture series on deep learning. The topic for today is long short-term memory, which is we call it as LSTM. So, have you ever wondered while typing in some sentences or keying in some sentences in your mobile phones, it automatically predicts the next word correctly? Or when you go to a Google Translator, it understands our sentences completely and gives us the accurate result. So, how does this happen? Yes, it is all because of the memory that has been into the network. So just like humans, how we forget some irrelevant details that we need not carry much irrelevant details to the future, as well as we carry in some information that is needed for the future as well. So the same way the machines has to carry out some information. So for all this, it needs some memory. The machine has to handle this memory very effectively. So when you take a traditional RNN or a vanilla RNN, this does not happen because it suffers from the vanishing gradient or the exploding gradient problems. So how does this is going to be handled? Yes, the solution for this is long short-term memory. Let us deep dive into what is long short-term memory. Let's see why this memory matters the most in neural network. So when you take a neural network, that is your traditional RNN, or when you take your vanilla RNN, what happens to the sequence of text is it is going to feed into the text at different time step. Is it not? So what happens is it loses the information or it loses the context of that particular sentence or that particular word. So when you take a voice assistant itself, when you feed into the traditional RNN or your vanilla RNN, it loses context while having your longer conversations. So what is the solution for this? How are you going to remember it for the long term? So the solution is LSTM. So just remember what humans do. So human memory has some memory in it. So it retains some long-term memory and it forgets the irrelevant details. For example, if I say the word, I was born in Chennai, I speak fluent. So the context, remember, is born is in Chennai. So the language that is being spoken is Tamil. So this will be remembered by the human memory, which is being captured for long term. So it gives auto predicts, we give the prediction correctly as Tamil. So can neural networks do the same? So if I give I was born in Chennai, I speak fluent, will the Google Translator or any other AI machines can able to generate the correct word? Yes, the neural networks do the same. So it learns the memory from the past information and it has some facts, context, past conversations also will be stored in a knowledge storage. So this is done using your long-term memory. So now let's see the technologies that uses this LSTM or long-term memory. So the technologies like Google Assistant, your chat box, your machine translation or your speech recognition all needs remembering some earlier sequence information. So for all this, the solution is going to be your LSTM. Now let's define why the simple or the vanilla RNN or your traditional RNN fails. So we all know a simple recurrent neural treats sequences one element at a time. That is, we are going to feed the tokens at different time steps. So for this example, I was born in Chennai, I speak fluent. So at the first time step, I is being fed into the neural network, then was born in Chennai at different time steps. Each token is being fed at different time steps. So when your RNN comes to the last stage, that is after fluent, it forgets the previous information Chennai. So this happens in your traditional RNN because it suffers from your exploding gradient problem. So the neural network cannot able to remember the previous information Chennai. So it lacks in predicting the next word. So for the problem that we have defined, so the solution for this is a LSTM. So this is a special RNN architecture designed to preserve long-term dependencies and also to avoid a vanishing gradient problem. So in this LSTM, we have the memory flow called the forget gate, input gate, output gate. So forget gate forgets the information that is not needed. The input gate allows the information, whatever the new information that has to be remembered, and with the help of these two, the output gate predicts the next one. So this is how the LSTM works.